Good day, learners. I hope you are doing very well. This is Elton from Maths and Science series. Today we'll be doing trigonometry, but specifically trigonometric identities. If you are in grade 10, if you are in grade 11 now, you were taught in grade 10 about trigonometry, and if you are in metric, you were taught in grade 10 and 11 about this thing called trigonometry. So in trigonometry we are working we are using angles a lot. That is why trigonometry, it is a study of triangles and angles. So the angles which we were taught in our earlier grades is theta, beta, and alpha. We work with those angles, and trig or trigonometric ratios. We have the sine of theta, cosine of theta, and the tangent of theta, then the reciprocals. But let us focus on the trig ratios, not the reciprocals. Now, we were taught that sine of theta equal to opposite over hypotenuse, and the cosine of theta we're taught that it is adjacent over hypotenuse. Then the tangent of theta, it is opposite over adjacent. So it is very important for you to know that. But there is a big chief known as SOHCAHTOA. So that SOHCAHTOA thing, it helps you to remember your trig ratios. So we have SOHCAHTOA, which is SOHCAHTOA, SOHCAHTOA. We split them into three parts. So or SOH, it is sine equal to opposite over hypotenuse. Then CAH, which is it is cos or cosine of theta equal to adjacent over hypotenuse. Then the last three, the TOA or TOH, it is tangent equal to opposite over adjacent. But we are not on that, we're just reminding each other about it. Today we are doing trig identities or trigonometric identities. So we have two types of trig identities, which are quotient identity and the square identity. But now the question, what is an identity? An identity is a mathematical statement that equates one quantity with another. A mathematical statement that equates one quantity with another, which means that an equation, we can refer it as an identity. These are identities which we will be dealing with. Now, as these are identities which we will be discussing about, so you must know the difference between the two. So as there are female and a male gender, so there is a difference. Even if we are even these two genders, they are called people, but there is a different there is a difference between the two. So same thing applies with these identities. So when you conclude saying this is it's a quotient identity, you must have a reason that I say it's a quotient identity because of this and that. Also, when you say this it's a square identity, I say that it is a square identity because of this and that. So it is very important for you to know that. So that's what we're going to discuss now. Then we do our examples. So we'll start by the quotient identity, our first identity. So whenever you see tan of theta, make sure that you replace it with sine theta over the cos of theta. Actually, we are not dealing with a tan. So whenever you see tan, replace it with sine of theta divide by the cos of theta. In identities, we are only dealing with sine and cos ratios only. Or you may be given tan squared theta. You replace it with what? With sine squared theta over cos squared theta. Even if maybe there's something like tan to the power 3 or tan cube theta, you will replace it with sine cube theta over cos cube theta if that thing exists. So I'm saying this so that you can understand what I'm doing here. So when you see tan, just know that we're not dealing with tan but sine and cos ratio. The second one, it is the square identity. Square identity. Yes. So remember in algebra we're talking about, okay, this is tan of theta. Now we're dealing with sine and cos. Now when we deal with the square, remember x to the power 2, which is x squared. So in square identities we must see the squared. So you must ask yourself, I put the square there. Now I said it is still a quotient identity. Why? Because we see the tan. All right. So here we have sine squared theta plus cos squared theta. So all the time you see this thing, we replace it by 1. This is a square identity. Why? Because we see the exponents 2 in sine and cos. So on tan squared theta, we say that it's a quotient identity. Why? Because we still see the trig ratio of tan. Don't say tan squared theta, it's a square identity. All right. So let us make the sine theta the subject of the formula. So we'll do what? We'll take this and transpose it to the other side. It will be 1 minus cos squared theta. So whenever you see 1 minus cos squared theta, you must know that it's what? It is sine squared theta, or you replace it with sine squared theta. I don't know if you get that. And now let us make the cos squared theta the subject of the formula. So cos squared theta equal to, you transpose the sign now. Since it is positive, when you take it to the right hand side, it will be sine squared theta. When it jumps the equal sign, it will be 1 minus sine squared theta. So when you see 1 minus sine squared theta, you replace it with cos squared theta. So the most important thing is for you to know how to differentiate between the two identities. Okay, they say simplify. So identities can be simplified or proved, or they can say prove these identities. Now we are just simplifying. So the most important thing, look what type of identities you are dealing with. So we have what? The quotient identity. So we must replace it with what? With sine squared theta over the cos squared theta times cos squared theta. So as on the left hand side we have a fraction, we can also make the right hand side to be the fraction, so we can deal with fractions both sides. So here this and this, it is what? It is sine squared theta cos squared theta over, then the denominator times the denominator, it is the cos squared theta. Now when you are here, you do what? You just cancel. Why? Because there's a multiplication sign. Now we are left with sine squared theta. So there's an alternative, you would have cancelled them on the first step. So identities, when you are asked to simplify identities, actually they're asking you to simplify to a single trig ratio. So the most important thing you must know, make sure when they give you whatever expression, you do what? You replace where you must replace. The second one, 1 over cos squared theta minus tan squared theta. The first thing you must do, replace the things which need to be replaced, which is the quotient identity that we are having there. So we just say write 1 over cos squared theta minus, then we do what we see, we replace by sine squared theta over the cos squared theta. Then after here we do what we do, the cross multiplication, or the LCD if you know it, but here we are using the cross multiplication. So 1 multiplied by cos squared theta, it is cos squared of theta minus sine squared theta multiplied by cos squared theta, it's sine squared theta cos squared theta, then over cos squared theta times cos squared theta, it is cos to the power 4, or you can write cos squared theta times cos squared theta. But even if you can write cos to the power 4 theta, it's still the same thing. Now on top you have what's similar on the left and what's similar on the right, which is the cos. You have cos on the left and also have cos on the right, which means cos squared theta, it is what the common fact. So when you remove cos squared theta there, you are left with 1, so that when you multiply these two, you'll get where you were. Now minus, when you remove the common factor there, you will be left with what? Sine squared theta. I hope you know this from algebra. Solve for x over the cos to the power 4 theta, or cos squared theta times cos squared theta. Okay, now we are not dealing with what, with the brackets, so we must do what, we must get rid of them. But before getting rid of them, we can do it, we can cancel the cos squared theta and the cos squared theta. Then inside the brackets, we are left with a square identity, which is cos squared of theta, remember, over cos squared theta. So go back and see the introduction of the identities. Now we are left with 1 because these are same values. It is like x over x, it is 1. So the most important thing, make sure that you understand your identities and replace them, and replace where you must replace with sine and cos. Now here's the third one. Look, you guys, the problem is that when you see something like something that is a little bit long, you just that thing just devastates you. But the most important thing, just do what you know. Then after that, it will lead you where you must get into. So the first thing here, we have what? We have a common factor here and there, which is what? The tan of squared theta, or tan squared theta. So before changing, just take out your common factor. Now when you remove tan squared theta here, you will be left with what? Cos squared theta plus, then when you remove the tan squared theta here, you'll be left with what? With sine squared theta. This is algebra. Okay, now we have tan squared theta, which is what, the quotient identity, and inside the brackets we have a square identity. Now just write your common factor. Now for substitution, you replace cos squared theta plus sine squared theta with 1. So anything multiplied by 1 is that thing. So here we have tan squared theta, which is our what? Our quotient identity. So even if you didn't change it, or if you can change it, it's fine. Now we have simplified our expression to a single trigonometric ratio. Okay, then do this one on your own. 1 minus sine theta cos theta tan theta. Then leave your answer on the comment platform. Then we will send you the corrections, only if you have you left your answer on the comment platform. So you can be asked to simplify or to prove identities. So here are tips on proving identity. So you must have this in mind, that sometimes I can be asked to prove or to do what, to simplify. So these are tips on proving identities. The first one, change all trig ratios to sine and cosine ratios, because we are not dealing with tan. Remember, we are changing, or we are replacing tan with what? With sine and over cos. The second one, choose one side of the equation to simplify and show that is equal to the other. You'll be given two sides. You choose one side to prove if that side is equal to the other side. I don't know if you understand that. Now there are other tips that I didn't write there. So the most important thing also, usually it is better to choose the more complicated side to simplify. You can add it on your notes. Sometimes we need to simplify both sides of the equation to show that they are equal. Usually it is better to choose the more complicated side to simplify, or we need to simplify both sides of the equation to show that they are equal. And a square root sign often indicates that we need to use the square identity. And when you see sine squared theta plus cos squared theta, just know that you need to do it. You now know that it is a square identity. I need to replace it with 1. It's not that when you see 1, replace it with sine squared theta plus cos squared theta. No. When you see sine squared theta plus cos squared theta, you replace it by 1. So this is what we are given to prove. Prove that the left hand side equal to the right hand side. So this is our square identity. So we need to prove it that the left hand side equal to the right hand side. So the most important thing, indicate the side that you are simplifying. So left hand side, now I'm choosing the side which I'll be using to simplify in order to prove that it is equal to the right hand side. So sine squared theta plus cos squared theta. So this is the side that I chose. Now you were taught that sine theta, we get sine theta by y over r, which is opposite over a hypotenuse. So as now we are given sine squared theta, we remember that we get sine squared theta, we get sine theta by y over r. Do not forget the squared. Plus adjacent, it's adjacent over hypotenuse, which is x over r. But do not forget the squared, x over r squared. Now when we are here, remember the exponents, the laws and the definition of exponents. So here we have what? We have y squared over r squared. Sorry about the bracket there, I was not supposed to put it. So here we have what? X squared over the r squared. Now let me cancel this bracket here. So this is what we have now. So we need to do what? To cross multiply. So here we'll have what? Y squared over y squared times r squared, which is y squared r squared, plus this times that, it is what? X squared r squared, over, now you multiply what? The denominators, r squared times r squared. This is r to the power 4, or you can just write r squared times r squared. But even if you wrote r to the power 4, it's fine. Now here we have what? Our common factor, r and r, or r squared. Now when we take out our common factor, we'll be left with y squared inside the bracket, plus, even here when we remove the r squared, we'll be left with x squared over over r to the power 4, or r squared times r squared. Okay, now we can cancel this r squared and that r squared. Now inside the brackets we are left with what? With y squared plus x squared over the r squared. Remember that this thing takes us back to the theorem of Pythagoras. We're taught that r squared equal to y squared plus x squared. So we replace what's up there, or the denominator, the numerator, by r squared, because r squared equal to y squared plus x squared. Therefore we have r squared over r squared. Theorem of Pythagoras, remember that. Now this will give us what? 1. R squared over r squared, it is 1. Therefore this was the left hand side. We were proving it, that is it equal to right hand side. Therefore we conclude by saying left hand side equal to right hand side. Now we have proven, actually you gave evidence that the left hand side is really equal to the right hand side. Now the second one, 1 over cos theta minus cos theta tan squared theta over 1 equal to cos theta. So the first thing, choose the side which you are working with, or the side which you will be using to simplify. Alright, therefore this is the left hand side, which is 1 over cos theta minus cos theta tan squared theta over 1. So this is the side which I'm choosing to work with. So it is very important to show the marker or the teacher the side which you would be working with. So 1 times 1, cross multiplication, remember it is 1, minus these times cos theta, it is what? It is cos squared theta tan squared theta over denominator and the denominator, they give us what? The cos of theta. So pause it and do it on your own, then refer the answers. Now here, that is when we must change our identities or replace with sine and the cosine ratios. So there you will have cos squared theta, then multiply by what? By sine squared theta over the cos squared theta. You can also do it on your steps there. Okay, this and that cancels, then we are left with what? With 1 minus the sine squared of theta. You see that? Alright, over the cos of theta. Then you see the denominator, the numerator, there we have 1 minus sine squared theta, which is what? Which is cos squared theta over cos theta. Now this can cancel that. Now we'll be left with 1 cos or cos theta. So it's like x squared over x. So our answer it will be x, because then the what? So left hand side equal to right hand side. So x cubed over x squared, it will be x. Why? Because the exponents are going to subtract one another. So the first thing, make sure that you replace what need to be replaced. Here's the third one. We have tan theta over sine theta minus sine theta over tan theta equal to tan theta over sine theta. So this, it is our left hand side, the side which we are working with. So we have tan squared theta minus a sine squared theta over this times this, it is sine theta tan theta. Now that is when we can replace sine tan theta with sine and cos. Now here we have what? Sine squared theta over cos squared theta minus the sine squared theta. Now remember, this over here, it is not that one, it is of replacing tan theta. So all over sine theta multiply by sine theta over cos theta. Remember that we have what? Theta there, so we are replacing it. So here we have a fraction, even here must have a fraction, so that we can deal with fractions both sides. So this times this, it is what? It is sine squared theta minus this times this, it is sine squared theta cos squared theta over this times that, which is sine, okay, over cos squared theta, then all over this and that. It is sine squared theta over the one there times the cos theta. It is cos theta. Okay, now we have a common factor there, which is sine and sine, or sine squared theta. So we take out the common factor, and inside the bracket will be left with 1. So that when we multiply this and that, will give us sine squared theta minus here. When we remove sine squared theta, or when we take it out as a common factor, we'll be left with cos squared theta. We are happy. This is what? It's a square identity over the cos squared theta. Cos squared theta. Now we can multiply, since we have a fraction there, we can say cos theta over sine squared theta. This is its reciprocal. I hope you know this from algebra. Okay, now what we can do here before continuing, because this is interesting. Now we write sine squared theta, then we replace that by sine squared theta. Remember, it's a square identity over the cos squared theta, multiply by the cos of theta over sine squared theta. Now when we are here, we can divide this by that, and the cos squared theta and the cos theta. Remember, we'll be left with cos theta here because there's an exponent 2. Therefore, we are left with sine squared theta, then over here we will be left with what? With cos theta. Remember that. Now if you can look your answer and refer it with the right hand side, they are not similar. Remember, I told that you might be forced or repelled to prove also the right hand side. Now sine theta over cos theta, we are replacing tan theta. Remember, multiply by sine theta. Therefore, numerator and the numerator, we have what? Sine squared theta over the cos theta. And if you can check now, they are similar. Therefore, you conclude by writing left hand side equal to right hand side, or right hand side equal to left hand side. So sometimes you can prove the left hand side and not get a similar thing as of the right hand side. Now use that right hand side to prove it that what you got on the left hand side, is it similar to what I will have now as I'm proving the right hand side. I'm challenging you now. Try to do this one and see if the sides are equal to one another. Now we have tan x plus 1 over tan x. Now I choose this one as my left hand side. Now so tan x over 1 plus 1 over tan x. I hope you understand why I divided by 1. So here we'll have what? Tan squared theta, cross multiplication, right, plus 1 there over the denominators, the product of the denominators, it is tan x. Now we have tan squared x and tan x. We need to replace them with sine and cos. Now here we have what? We have sine squared x over the cos squared x. Why? Because that's our quotient identity over the sine x over cos of x. All right, now over 1 here, this times this, it is what? Okay, equal to sine squared times 1, it is sine squared x, plus 1 times the cos squared x, which is cos squared x. We are here, this is a square identity. This times that, it is cos squared x, now times the reciprocal which is cos x over sine x. Now here we have what? We have our square identity, which is 1 over the cos squared x times cos x over the sine of x, even if you cancel them. So these which is 1 over, these will cancel that one. Remember, we'll be left with cos x because there was exponent 2 there. So cos x multiply by, we are left with 1 there since we cancel the x. Then we multiply the numerator and the denominators. We have 1 over the cos x and sine x, cos x times sine x. So when you compare them, the answers with the answer that you got with the right hand side, they are similar. Therefore, you just write the right hand side equal to left hand side. I hope you now know how to prove and simplify the identities. So I will give you other activities to do on your own. If you can try to prove all of these identities, it won't be or there won't be any identity that can smash you or that you can't know how to prove. So thank you guys. I hope now you understand. So to make sure that you really understand more about proving and simplifying, make sure that you try to prove these 10 identities. Do not forget to comment and share.